Hello and welcome to another video from the Introduction to Machine Learning lecture series. This is a beginner friendly course, so if you have not done any machine learning, do not worry, this course will set you up. So save this playlist and follow along to learn more. So in this video we are going to be discussing ridge regression, which is another type of a linear model. Ridge regression. Ridge regression is also a linear model for regression. Ridge regression is a model tuning method that is used to analyze any data that suffers from multicollinearity. So multicollinearity we have discussed in the previous video. The formula it uses to make the predictions is the same one used for ordinary least squares, also called as the regular linear regression. So I'll just write down the formula. So y equals to w naught x naught plus w1 x1 w2 x2 and so on up till wn xn, where n is the number of input features, and then finally the intercept, y-intercept. Okay, so this is the same formula which we use for the regular linear regression, and this is the same formula will be used for ridge regression as well. So the next topic that we have is regularization. So regularization is explicitly restricting a model to avoid overfitting. Sometimes the machine learning model performs well with the training data but does not perform well with the test data. It means the model is not able to predict the output when dealing with unseen data by introducing noise in the output, and hence the model is called overfitted. This problem can be dealt with the help of a regularization technique. So how ridge regression works? In ridge regression, the coefficients W are chosen not only so that they predict well on the training data, but also to fit an additional constraint. We want the magnitude of coefficients to be as small as possible. In other words, all entries of W should be close to 0. Intuitively, this means each feature should have as little effect on the outcome as possible, which basically means having a small slope while still predicting well. This constraint is an example of what is called regularization. The particular kind used by ridge regression is known as L2 regularization. So let me write down the formula first. So we have y equals to w naught x naught plus w1 x1, and this continues up till wn xn plus b, where b is the y-intercept. So the idea is to reduce these values of w so that they have little impact while training the model. So there's a parameter which helps us do that. So we'll discuss that in the next slide. The alpha parameter. The ridge model makes a trade-off between the simplicity of the model coefficients and its performance on the training set. How much importance the model places on simplicity versus training set performance can be specified by the user using the alpha parameter. By default, parameter alpha is equal to 1. Increasing alpha forces coefficients to move more towards 0, which decreases the training set performance but might help generalization. So there's a choice that you have to make between whether you want the model to perform well with the training data, or do you want the model to perform well with unseen data. So in the first case, what happens is all the input features are taken into consideration. Okay, so that leads to overfitting of the model. So if you have if the data is from that particular training data set, so the model will perform super good, it will be able to predict the data because it already knows what the outputs are, right? It has memorized. But what happens is if you feed some unseen data into that particular model, the performance is pretty bad. So the idea is to reduce the impact of all these input features by reducing the value of the W, or tweaking with the alpha parameter, which in turn changes the value of W or reduces it, so that the impact of all these input features decreases, and we have a much simpler model. And then if you are inserting or feeding some unseen data into that particular model, so it will be able to perform better. So this is like a choice that you have to make, but mostly we want our model to perform good with unseen data. So that is the central idea. So this is how Ridge regression is advantageous compared to our regular linear regression. But data is king. With enough quality training data, regularization becomes less important, and given enough data, ridge regression and linear regression will have the same performance. Also, if more data is added, it becomes harder for a model to overfit or memorize the data, avoiding overfitting. Okay, so now I'll open the Jupyter notebook and see how to implement the ridge regression. So I have opened my Jupyter notebook, and at first we will import the required libraries. Okay, so we import pandas as pd, we import numpy as np, we import matplotlib.pyplot as plt, and also we import scikit-learn. Next, we create a variable named df, which stands for data frame, and using pandas.read csv, read our csv file and then print out the dataset. So we have age of the person, then sex of the person, then body mass index of the person, number of children that person has, if the person is a smoker or not, and the region he or she is from. Okay, and based on all these parameters, the insurance cost is calculated. So next we can see that there are a few string values. So what we want to do is we want to replace the string values with integers. Okay, so this integers will basically be like, will act as identifiers. For example, so suppose we want to replace, we use the replace method and replace male and female, right? We want to replace male and female with which example we want to replace male and female with 1 and 2. Okay, so basically 1 will mean male and 2 will mean female. So now if I try to print out the data frame, we'll see our the sex column is replaced with numbers 2 and 1, where 2 means female and 1 means male. Similarly, we want to get rid of this the string values in the smoker column and region column. So what we'll do is we'll replace those as well. So we need to replace smoker, if the person is a smoker, yes, no, with some integral values, but these are like binary, so we can use 1 and 0, which is pretty standard to use 1 and 0 for yes and no questions, right? So and once this is done, we also want to replace the region. So we want northeast, then southeast, northwest and southwest, and replace it with 1 2 3 and 4. Okay, wait, we have an error. Oh sorry, I should be using value, made a mistake. Okay, so yeah, so now if I try to print out the data frame, our data set has all integral values. Now what we can do is we can sort of create two variables, x and y, where x is equal to, we have age and the sex, then BMI, if the number of children, then smoker or not, and the region he or she is from, and the y value will be equal to the output, which is the charges column. Okay, so these are the variables that we have created. Now from sklearn dot model selection, we import train test split function, which will be used to sort of like we have this data set. We want to divide this data set into two parts, where one part will be used to train the model and the other part will be used to test the model. Okay, so the test data is basically the unseen data, which will be using to sort of test the model. Okay, and then based on the predicted values and the true values, we'll be able to see the comparison, like how well the model has predicted. So now we create these variables: x train, x test, y train, and y test equal to train test split. These are pretty conventional, and we want to pass x, y, then test size, let 33% of the data to be like we want 33% of the data to be in the test set, and we have random state, we'll give a value of 0. Okay, so now from sklearn dot linear model, we can import ridge. Okay, and we'll create a variable called ridge and instantiate our ridge class. Okay, so now we can start our training. So we'll use the fit method to sort of feed the train, and so we'll use the fit method to train our model. So the data we feed into this training are this x train and y train. So the once this is done, we can sort of create a variable called y prediction, and using the predict method we can sort of start predicting the values. Okay, where in the predict method we have we have passed an argument x test, which includes all this column values. Okay, age, sex, BMI, children, smoker, region. Okay, and based on these, now after the training is done, the model will start predicting, and the charges that the model predicts are these values. Okay, so the charges, so the insurance charges predicted by the model are these values, right? So now what we can do is we have the true values under y test variable. Okay, y test are the true values, okay, which were actually there. Then y prediction are the values predicted by our model after the model was trained. Now if we try to plot the y test, okay, let's use square to represent the data points, and the label would be true values. Okay, similarly we also want to plot the predicted y values, or the predicted insurance costs by our model. Predicted values, and we use this legend function to sort of show the labels on our plot, and finally we'll do a plt.show to show our graph, to show the plots. Okay, so as you can see, the squares are the true values, and the circles or the orange ones are the predicted values, right? So now if I try to print out the training set score. So we'll have rich dot score x train and y train. You can see that our training set score has a 72% accuracy, and the test set score will have rich dot score x test and y test. We have approximately 78% accuracy. Okay, so we can also trick the alpha value. So by default the alpha value is equal to 1, but we can also change that to, for example, 10 and maybe 50. Say for example 50. So if I run all these cells, so see the training set score has reduced, and also the test set score. So the model becomes much more simpler if we increase the alpha value to 50. So I think 1 works just fine for now, because if I try to reduce it to 0.1, let's see what happens then. It is approximately same, just a bit more accurate, because when we used 1, when the default value was taken, alpha equals to 1, we get 78.5. so I think 0.1, so I think 0.1 works just fine, so we'll keep it to that. So this is the ridge regression implementation. It is mostly used where we have this case of multi-collinearity. So make sure that you use ridge regression over the regular OLS or ordinary least square. So in the next video we'll look at lasso regression, and then do a comparative study between all these three: OLS, ridge and lasso regression. So if you found this video helpful, please give it a like, share it with your friends, subscribe to this channel and hit that bell icon so that you do not miss out on any upload that I do. Okay, so thank you so much for sticking by, and I hope to see you guys very soon.